Okay, so now let's see this question. Two cards are dealt from a shuffled deck. What is the probability that the first card is an ace and the second card is a face card or a 10? Okay, so let's do first. Let's calculate the first probability. First, we have 52 cards in the deck of cards. How many aces in the deck? We have 4 aces. Going back here, one of each shape. We have 4 aces. How many face cards are in the deck? So we have 12. We already saw that, 12 face cards. How many tens? Back here we have 1, 2, 3, 4 tens in the deck. Okay, so again, what is the probability that the first card is an ace? So this is an easy case. The probability for an ace as the first card will be 4 aces. We have 4 aces out of 52. Okay, so this is the probability that the first card is an ace. Since the first card was not a face, okay, because it was an ace, what is the probability that the second card is a face card? So remember, we took out the ace, we didn't put it back. So now let's go back to our deck. Now we have one card out. One of these is out, not all 3 of them, but we know that the first one was an ace. It doesn't matter which one. Let's say this one, we're going to cancel it out. Okay, we don't have it anymore in the deck. And again, it can be any one of the other aces. The point is that after we draw one ace, we have 53 cards left in the deck. So the second card, okay, we were here. The second card to be a face card. Now we have 12 face cards, but we only have 51 cards in the deck. So it's 12 out of 51. Or now this is this or this. Okay, this or this, and this has to happen this and this. So so the first we said for face, we know it's 12 out of 51, and the other condition was where is the question? The second card is a face or a 10. So what is the probability that the second card is a 10? So again, we have 4 tens in the deck, but we have 51 cards left. So it's going to be 4 of 10 is going to be 4 out of 51. Remember, it's this or this. We didn't take that, and now we're trying this one. Otherwise, there will be 50 cards in the deck, but we didn't do that. So it's either this or that. So now let's get to the math. Ace, okay. So let's see. So we have, what is the probability that the first card is an ace and so we multiply, the second card is a face or a 10. Okay, and we have to put parentheses here. Okay, so it's this and this. And here we have two probabilities, this or this. So remember, or is plus, and is multiplication. Or is addition, and is times or multiplication. So now let's put the numbers that we calculated. The probability for the ace was 4 out of 52 times Here we have probability of phase. Let's go back here. 12 out of 51 and 4 out of 51. So we have 12 out of 51 plus 4 out of 51. Okay, so we have to do the math. Here we have, let's continue. This is 4 out of 52. And here we have, this is the same denominator. So we just add the numerators. We will have times 16 out of 50 over 51. And let's do that. This is 64. And 51 times 52. Let's use the calculator for that. 51 times 52, 2652, 2652. We can reduce that, but let's just use the calculator. So 64 divided by 2652. The answer is 0.024. 0.024, and we can write it in percents. Remember, decimal point move 2 spaces to the right, so we have 2.4%. So you see here we have the fraction. Of course, it can be reduced, but it's still a fraction. And we have the decimal, and this is rounded. Okay, so this is a rounded number, and here we have our percent, which is also rounded based on the decimal. Okay, let's continue with that. Conditional probability. So you write conditional probability with P. That's the probability of event to happen. That's an event that happens. The probability of an event to happen that we previously know that A happened. This event was given. This probability was given. So for example, one card is drawn from a shuffle deck. The probability that this card is a queen. So we already know we have 4 queens in the deck. We have 52 cards altogether. So the result will be 4 over 52 or 1 over 13. So if I already know that it's a face card, okay, I draw the card out of the deck. I tell you this is a face card. You don't see the card, but I'm telling you this is a face card, and I'm asking you what is the probability that it's a queen now. So now the whole thing changes. Now it's not 52 cards. You know that there are only 12 face cards in the deck, and there are 4 queens out of that, and 4 out of 12 is 1 out of 3, a third. Okay, so given the information that it's a face card, the probability that it's a queen now is different than just drawing a card out of the deck without knowing anything previously, and the probability in this case will be 1 out of 13. In this case, the probability is much higher. But again, you have to know that information. Okay, so the probability for 2 events, A and B both occurring, will be the probability of event A, again, event A and B will be the probability of event A knowing that B happens times the probability of event B. Or event B knowing that A happens times the probability of event A. And again, if they're independent, then it's just what we learned before. But if they're not independent, you have to use this equation. We'll see some examples later. This leads us to an equation which is called Bayes' theorem. This calculates a conditional probability based on always the condition might have occurred. And we will see an example in the following. That it might look like a complicated formula. It's long, yes, but once you know which one is each one of these probabilities, then it's just going to be plugging in numbers and it's very easy to list these elements based on the givens. You're going to see it in a moment. So this is the question. LCD screens components for a large cell phone manufacturing company are outsourced to 3 different vendors. For example, let's say that LG, I'm just giving an example, that LG don't manufacture the screen themselves, they only assemble them, and they purchase the screens for their certain model of phone from 3 vendors. Okay, vendor A, B, and C. Vendor A supplies, you see that the colors match here or corresponds with the number of vendors. So vendor A supplies 60% of the screens, vendor B supplies 30% of the screens, and vendor C supplies 10% of the screens. Now, so you might let's continue, and then we'll go with some questions that might rise here. So quality control experts have determined that 0.7 of vendor A screens, 1.4%, 0.7%, 1.4% of vendor B screens, and 1.9% of vendor C screens components are defective. Okay, so vendor A will tell you, listen, you buy from me 0.7% out of 1,000 screens, 7 are going to be defective. I know that. I'm not going to tell you which one are defectives. I'm not going to do that test. You're taking the risk, but I'm going to give you a discount, okay? Because 0.7% are defective. And vendor B will tell you the same, 1.4%, 14 screens out of 1,000 are defective, okay? And vendor C will tell you 19 out of 1,000 are defective. I'm not going to check it for you. Why? Because to check if a screen is defective, you have to assemble it first, or the rest of the phone, and then you can tell if it's defective or not. So they're not going to assemble the screens. Let's say that you're the cell phone company, manufacturing company, and you're going to assemble them, and then you're going to check. And if it's the wrong screen, you're going to replace it, throw it away, or return it to the vendor. It depends on the terms that you have with that vendor. So first question, before we even start with the probability, and the question itself, is why would a manufacturer go to B and C when they can only buy from A? So take a moment to think about it. Okay, you can pause the video to think about an answer and write it down. Okay, pause now. Okay, so I'm going to answer this question. Usually it's risk management. Let's say that vendor A goes bankrupt, and now you're going to order from vendor B, but it takes time for vendor B, to prepare your request. They have to take measurements, to do the design and everything. So it takes a couple of months just to before they start manufacturing, the preparations, the design, and the prototypes and everything. They have to start doing that. So if you got to the shopping season, okay, and you only have vendor A goes bankrupt, you miss the season, because vendor B and C, until they're ready to manufacture for you, it's going to take a lot of time. So it's mostly risk management, even though vendor C gives you 1.9% defective components. But again, you're going to test it, and you're going to either deal it with your own customers, or just test it and return it to the vendor, or get a refund for it. But the vendor will not tell you which one is defective. They tell you, we check them, we do sampling, and we check that 1.9 are defective. Deal with it. So now the question is that if the cell phone was chosen at random, now you have a bunch of cell phones, they're all mixed. You don't know which one comes from which vendor, which one screen comes from which vendor. You mix them all up. And the LCD screen was determined to be defective. What is the probability that the LCD screen was produced by vendor A? Okay, so this is the question. So how do we approach this kind of question using the Bayes theorem, or this formula? First, we list everything that we know. We have 6 numbers here, okay? The 3 different vendors, how much we buy from each one, and then we have defective ratio. So let's see how we list how we solve this problem. Let me go down here. So let's start with this. What is the probability that the screen is from vendor A? Okay, this is simple. 60% are coming from A. This is going to be 0.6. Okay, that's the probability that's coming from vendor A. And from vendor B, we have 0.3. And from vendor C, we have 0.1%. And it's not percent, it's 10%. So going back to the question, 60%, 30% from vendor B, 10% from vendor A. So now the next thing that we're going to list is the known. Now, what is the probability that it's defective if I know that it came from vendor A? So this is something the vendor tells me, or the quality control specialist found out. If it's coming from vendor A, there is a 0.7% probability that it is defective. So let's write it down. Again, the probability that it's defective, knowing that it's coming from vendor A, this is 0.7%. But since we didn't write the previous one in percent, and for calculations, you don't want to use percent, you just need to convert it to decimal. So we have 0.007. And for vendor B was 1.4%. So I'm going back here, and this is going to be 1.4% or 0.014, and the last one is 1.9% and 0.019. Okay, so now we know all the probabilities that it's coming from the vendor, and all the probability that if it's defective, what is the probability that, sorry, if we know that it's coming from vendor A, what is the probability that it's defective? Remember, the right side to the vertical line, this is not a backslash. This is a vertical line. So the right side is what we know, okay? And the left side is the probability. What is the probability that the screen is defective, knowing that it's coming from vendor A? So now that we have all these numbers, all we have to do is plug in. Okay, so let me write it. This is the equation. I'm going to do the plugin here, and the calculation is going to happen here. So here we have, again, all the numbers that we're looking for are the givens. Okay, all the numbers are given. So let me replace first. What do we have here? Equation is here. So we have PA, PB, and PC. So I'm going to write these numbers first. The probability is from vendor A, that's 0.6, 0.6, 0.3, that's PB, and PC is 0.1. Here we have times, 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 times. And then we have probability of defective knowing that it is from vendor A. So we have it here. Okay, we have the number here. This is 0.007. 0.07. Also here. Okay, we have this value here and here. So 0.007 plus 0.3 times this value. It is defective, knowing that it's coming from vendor B. That's 0.014, 0.014 plus 0.1 times 0.019. Now we have to go to the calculator. It's a little bit difficult to do this mental math, but will take you a couple of hours. So I'm going to do it in two steps. No, actually I will do it in one step. I will just use parentheses here. Okay, remember, if using a scientific or graphing calculator and you have addition, even if you don't have addition, always use parentheses on the numerator, on the denominator. Okay, the numerator is less important unless you have addition here. But it will be best if you put parentheses on the numerator as well. Okay, just it's a good habit for using calculator. Okay, so let's go back here. No, sorry, right here, and back to our calculator. So I'm going to start with, let me clear the memory, start with parentheses. We have 0.6 times 0.007, okay, in parentheses, okay, this is our numerator. And then divided by the denominator, we have 0.6 times 0.007 plus 0.3 times 0.1014 plus 0.1 times 0.019, and end parentheses and equal. Okay, so this is our probability, and the probability is 0.04. And let me just go over the numbers. 0.1. Yeah, so the probability is 0.04. Let's see the other digits. 407. So I'm going to round the 7 to, I'm going to round the 0 to 1, 41. Or in percent, it's 4.1%. So again, if the screen is defective, the probability that it's coming from vendor A is 4.1%. Now, this is another two examples of the original question. So what is the probability that it's coming from vendor B or from vendor C? I'm not going to calculate it. This is your practice calculation, but basically the only difference is that here in this equation, instead of using this, if you want to find from vendor B, okay, if this is B instead of A, this will be your numerator, not this. This is the numerator now, but this will be your numerator, this part. And if the answer is C, then this will be your numerator. The denominator doesn't change. The denominator remains the same for all three, A, B, and C. So this is for A, we did that. This is the numerator for B, and this is the numerator for C instead of this term here. So that's it. So you can try and calculate it yourselves, and that's it. This concludes the presentation, and if you have any questions, you can add a comment, ask a question, and I will do my best to reply them, or you can send me an email. Okay, goodbye.